So welcome to this panel. The title of this panel you will see is Enhancing Intelligent Tutoring Systems with Large Language Model. So we have a few panelists, and then to discuss this. Let me see here. Okay, come on. Where's the? Trying to make this one. No. Okay. Okay, so this is what we're going to cover. We're going to talk about in this hour, and we have a total of 4 panelists, and I'm going to be the one that asks questions, and they're going to be discussing the issues, and then I think Richard and Cronin going to have a slide or two to share, but at that time that you do take control. So we have first Richard. He's technologist in AI and then EduTech, the chair of IEEE Artificial Intelligence Subcommittee. And we have Professor Ming Chi from NC State. And we have Andrew Olney from University of Memphis. And we're likely to have Gautam Biswas from Vanderbilt. And then I am Xiangen from University of Memphis. So first, so this is everybody. So I'm going to go through this one and ask questions every day. When I ask a question, I will show the head. Okay, that way, so you know who is talking. Of course, you can see us. Okay, so my first question would be Richard. Okay, Richard, given that your key role is in IEEE standards for AI and also learning technologies, how can these standards be extended or adapted to ensure that large language model integrated ITS interact ethically and effectively with students?
Well, actually, thank you again. It's really an honor to be here with really accomplished researchers and educators to talk about this. I would like to share a quick slide to illustrate a little bit of my organization. And actually, let me see. Can you see my screen?
Yeah, yes.
Okay, so if you see this diagram, it's a very complicated diagram, but if you think about it, this is all the standardization areas that we have for AI under the IEEE AI Standardization Committee. And so currently we have about 40 working groups focusing in these areas, covering a lot of different things. But I would say there are 2 main things. One is on the policy side, the other one is on the technology side. And both are relevant for the education, even though the standardization process and the standard development organization is for the whole AI industry. So I would say there are 3 relevant standardization efforts that is related to ITS. First is at the policy level, right? So we're talking about the standard that assures, like for example, explainable AI, the ethical interaction between the AI and the human, data security, privacy, educational accessibility, also a lot of the things related to risk, accountability, and all these protections of potential misuse of these AI technologies, right? So like data governance and trustworthy computing. So that is one big area that could definitely apply to the AI, especially AI. We're targeting a lot of the young people, and that they're more vulnerable, especially like we have standards that need to accommodate legislations and regulations such as FERPA or HIPAA or now the EU AI Act and all these other things. The second area I think is really relevant is related to the application scalability. So the standard we have are aimed to make sure that the systems are cost effective and widely accessible. Standardization level the playing ground for a lot of the smaller vendors, and also for students who face kind of like more economic and social challenges, because for them, cost and accessibility is very important. When you have something that is standardized, it typically makes the whole cost much cheaper to develop, to deploy, and also to make it more accessible to students and teachers who are more economically challenged. We're not just cutting costs, we're really expanding reach, right? So that is a really huge area that IEEE and our standardization effort, along with our partners like in ISO, in also other standardization bodies, to really advance the accessibility and reach for our AI technology. And the third one, we're also talking about the future frontiers, because artificial intelligence, especially artificial general intelligence, and the things that we are building for ITS, such as self-improving AI and AI that are much more capable in areas such as multimodal AI and AI that reach the capabilities of human or superhuman level. And in that case, education is not only a beneficiary of AI, it could also be a great testing ground and contributor to advanced AI itself. And that area, standardization, is also playing a big role, because a lot of the things that coming from the AI use case in education will help to feed into and evolve our understanding of how this standardization can help the overall innovation and pushing the boundary of the innovation itself. For example, the standard that we're building on, like the AI agent standard, some of the multimodal related to AI standard, and also the large language model evaluation, and some of the newer things related to kind of like a more AGI type of advances will greatly benefit education, but also, again, education will be a major contributor to the AI. Like, for example, the work that we're working on, like the neural symbolic AI cognitive architecture and these advanced AI capabilities, that will all benefit, right? So sorry to take that long, but this is definitely something that we feel are really very relevant. And thank you for the opportunity to kind of like promote our efforts. Yeah,
I think this is great to get us started, because ITS standards has been an issue or has been challenging for all the researchers in the past. So given the large language models, what challenge do you think the large language model, especially like the OpenAI or other models, actually making the standardization easier or harder? Because we know it was very hard before. We have tried many effort to make it happen, but was never successful. Now we have large language model. Do you think it's making it easier or harder?
Well, I mean, large language model makes everything easier, but also it opens new paradigm shift, right, in this effort. Like, for example, in ITS, we're talking about like a standard that target the core of the ITS, like we work on the adaptive instructional system standard that has 4 key models: the interaction model, the pedagogy model, the domain model, and learner model. And all those models now can be supported by AI agents. And that opened up a really new frontier for this AI agent to come into a complex learning environment and support advanced AI and human interactions, where complex contextual information can be fusion is like a fusion of all this information coming from the 4 base models can go into that. Actually, let me show, there is a diagram I have here that I show a little bit of that. hold on, like this chart, right? Well, this maybe like this one. So if you look at the, in the adaptive instructional system, which is another name for the ITS systems, you have these 4 key models: the learner model, domain model, pedagogy model, interaction models. And these models, if you combine that with the agent, like the agent that we're building is called NeoLAF agent, it actually can fuse them together and generate very dynamic, both outer loop and interloop interactions with all kind of different interactivity patterns that traditionally was unthinkable, right? So these are definitely, we're opening up a whole new frontier. And also the future of application, like the application like Dr. Hu you have built, basically make the building of this application, deploying of this application, and also accessibility of these applications much easier with a, not only the chat interface, but also interface generated dynamically by the large language models and the content dynamically generated by large language models, right? And the standardization can certainly help in these areas. Okay, yeah.
Okay, thank you. I think as far as I understand, the existence or development standards, the necessary condition, it's actually it's mature. The field is mature, right? So in other words, once you are mature, have a matured field, and then the indication is having a standard. So now we have me as a learning scientist. So we're going to see how mature this field is, and also so how you to approach. But first, I want to ask a couple questions about random questions about your research and this, right? So I'm going to share this one here. So this is me. Okay, so I have a couple questions. Our panel actually, what I prepared is ask one researcher, 2 questions, and then we're going to have if we have a time, we'll have a round of discussion. So, Min, I want to ask you the first question. Is based on your extensive research on machine learning models for educational software at NC State, and also before you actually went to NC State. What are the most important factors to consider when integrating large language models into ITS?
Excellent question. And I think I know when I started doing research in ITS was pretty mature. That time started, but it's not booming. And at that time, one of the biggest concern for ITS is going to classroom in the 1997 class paper, right? And from Ken Kininger, teachers think it's a threat. I feel like ChatGPT has a similar situation these days. And in North Carolina, where we live, we have a county basically banned ChatGPT for K-12 education. And so that's kind of what we can see that ITS encountered previously. ChatGPT is encountering to some extent now. And to incorporate ITS to the classroom, I think ChatGPT has considered all the factors about how we incorporate ITS to the classroom. We have to think about who is the user, what is the educational goals, what is the objective. And a lot of times we design a tutoring system and teachers are not going to use it because they can't combine into their classroom. If they can't operate and change the content, they are not going to use it. And so for ChatGPT to be able to be leveraged in with ITS, and I think one of the biggest things is they should have aligned same educational goals, objectives, and also content has to be aligned. And so another example, another thing we have to align is pedagogy. ChatGPT tried to generate things that maybe make the conversation very smooth, but not necessarily to improve student learning. And so there is, and the same conversation makes student learn is different from the same conversation make you feel good. So that's kind of how you transfer, kind of see which kind of the best strategy to communicate with ITS and combine the ITS go with the large language model is another thing. And most of the ITS these days, we try to provide a personalized learning experience. And similarly is how we can combine the large language model to be adaptive together with ITS is another factor, and assessment and so on. So I can go on, but that's what I can think of. Another thing is trust. And we have a lot of ITS concern about student trust our system and so on. But same thing when we can trust the large language model to generate the answer, especially if you generate some misconceptions. Students, once exposed to misconceptions, that can be very, very hard to be corrected.
Mm-hmm.
I hope
I agree.
Mm-hmm.
Yeah. Actually, the ChatGPT or a large language model is not produced for learning. So now we want to make it for learning like ITS. We have to do something. So as a learning scientist, study the modeling student behavior. So what do you think about how do your work on the modeling of student behavior and cognitive processes that really make the large language model working for ITS? Again, the large language model is not built for learning, and then you are a learning expert. So how can you help, if possible, help make the large language model that work for to help students learn? Okay.
So you feel like a student modeling, right? I think
Yes.
To some extent that student modeling and ChatGPT have similarities. They try to model something. One's model the big language, the content and so on. Student model, we try to model student knowledge and how they grasp the content. And so there is clearly there is a similarity in a general sense, and we can basically say using. So a lot of times the student modeling, you model students' behavior using fixed content, right? With the system designed this way, student can only behave this way. And now we can only model students certain like knowledge, do you master or not master. On the other hand, the language model can make our modeling, student modeling much more richer. They can generate new content that I think that Andrew is expert on that. And also we can model something more like how students interact with large language modeling. That is more interesting than just model whether the knowledge is mastered or not. And because the student can cheat on the exam, but student cannot cheat on how to interact with existing agent, their temporal behaviors. And another thing is about cognitive, right? And I think similarly, cognitive was including all kind of motivations, and it's much more complex, and also it's kind of relevant to how students solve the problem. What is their metacognitive skills? And those things generally is very hard for ITS to grasp. We generally looking at how students interact with tutoring system, and sometimes the best way to grasp that is through dialogue. And because the limitation of natural language understanding in the old tutoring system, so we can't do a good job. But these days, I think with a large language model, we may be better model student metacognitive skill and think aloud, protocols and so on. Yeah.
Okay. So last question. So you actually started, you design learning systems, and also through your learning system, you actually study human behavior, and also your system, you can, since you designed the system, you actually can implement pedagogy, right? Can you imagining that a large language model through prompt engineering, actually you can make or teach it to adopt effective pedagogies?
I think one of the things, and that's great. So there's a lot of things when we in our research, we're using many student interaction logs. We use reinforcement learning to try to see what's the best pedagogy decisions the tutor should carry out, intervene to improve student learning gain. And that's like a ChatGPT is basically also use a lot of reinforcement to learn how to adaptively to each user's need, right? And in that sense, it's very close to our approach. And what is different, opportunity is a lot of times students feel like the tutor is too centric, too dominant. When you make a decision, and it is really hard to explain the decisions to the student. So that's why we think a large language model can communicate the decision. You use natural language to say, we choose this decision because certain factors to save you time, to make you learn better, and so on. So much more like a data-driven explanation for the pedagogy. And I think that's one potential way we can make our pedagogy better. Yeah.
Okay, we're gonna have a discussion later for this. So next, I want to invite Andrew Olney to talk about data, because Andrew Olney, you are a previous editor of Education Data Mining, and I know that you're expert of natural language. And I was gonna find time to really ask you about large language model, but I know that even way before this, you were doing language models. So my first question is, given the experiences, what are the specific type of data that should be collected to optimize the performance of the large language model? Given that right now people are thinking about building their own large, like a local large language models, and for the specific purpose of integrating ITS.
Yeah, I think that's a really interesting question. So my research history, the approach that we've used, we like to study the phenomenon in context, right? So if we want to study tutoring, we'll find good human tutors and put them in front of students and record that interaction, right? And then the historical way of analyzing that data is to use a coding approach where we might say, oh, the tutor has asked this kind of question and the student responded, and the student's answer is missing some elements, and the tutor gives some kind of feedback, and we analyze all these dialogue patterns, right? So the interest with large language models is that some of these traditional practices are maybe relevant in a different way than they were before, because now the large language model can basically predict what's going to happen next, right? And so some of this coding that we've done based on our own theoretical conceptions of what's happening isn't really necessary in the same way in order to build a system, right? We can now build a kind of theory agnostic system that's just driven by the data. But on the flip side, from an analytical perspective, it makes it kind of hard because now we need to know what ChatGPT is doing. So if we want to analyze what ChatGPT is doing, then we need to go through the same kind of process where we're coming up with these theoretical codes and we're analyzing the ChatGPT data by saying, oh, ChatGPT was doing this, just like we used to do with tutors, right? So it's a very interesting situation to be in, right? It's almost like before we were kind of like psychologists trying to understand human tutors, and now we're more like psychologists trying to understand ChatGPT, or just I'm generically saying large language models. I think I used ChatGPT as an example. And certainly from an educational data mining perspective, we're looking at data that's it's unstructured data, right? It's natural language text data. So that's really the point. And so, some of the interesting things that I think we can pursue here is, how reliable is a large language model in maybe helping us code its responses. Does that even work well? And I think it just gets into some of these larger integration issues that Min was describing. Like what's the best way to do an integration where we don't want the language model to do everything, where we maybe want it to do some things but not other things. And so if we have a separate student model that we want to somehow have the language model interface with, how do we do that? How do we get the language model to respond to what's in our student model? And how can we get the language model to update our student model? So these are, I think, pretty challenging questions that no one has, as far as I know, no one has a very good solution to yet.
Absolutely. In other words, the question is along the same line. It's before when we do educated data mining, we actually design a system interacting with the student. So we're not really data mining, more like data farming. In other words, we almost know what they are interacting. We give them test questions. In other words, we have more control. Right now, large language models, and let's implement it into ITS. In itself is actually we cannot control it very well because it itself right now is truly kind of data mining, right? In other words, the way that before we have almost to control the learning environment to collect student data, analyze the script. Right now, we do not actually have controls. So how can whether the educated data mining methodology that we have used before how easy it is to extend to study this kind of data?
Right. And I think that's it's a tough question. So, I mean, I can imagine two different scenarios right away. So in one scenario, what we're giving to the language model is like very, very short instructions, right? So let's say that I'm having the AI is having a conversation with a student, right? And we may tell the AI, hey, we want you to deliver a prompt question right now. We want you to create a leading question for the student because the student is not doing too well and needs a kind of hint. So we want you to generate that for us. So if we create instructions at that level of granularity, then in our data, all of our data logs, we can code that that's what it did. Of course, it may do something else, but we can code that that's what it did. But, I wonder if that's really making full use of the advantages of a language model. If we're that granular, it seems like we're not really leveraging it very well. So if instead we give it more control and we have it generate, the entire interaction or much larger units of interaction, now we're looking at like free range natural language input, just as if a human had created it. And now we have to go through this really arduous analytical process of trying to figure out like what exactly did it do, right? Which I'm not sure we can do in real time. Maybe we'll be able to do that. Maybe we need to have a language model that analyzes another language model. Maybe we need to fine-tune language models so that instead of using it in this kind of chat GPT way where we have these prompts and everything, maybe we need to take an existing language model and we need to fine-tune it so that we can give it kind of like more symbolic inputs that are then driving the generation to, but these are all possibilities. I'm not sure that these possibilities have been very well evaluated at this point. So I think there's a lot of very interesting work to be done.
Yeah, I think the one thing that I would like to just maybe we can find out a time later to discuss this one. For example, right now, a lot of people using ChatGPT to analyze data. And you use the open large language model to interact with the student, and you use large language model to analyze data. Supposedly, you also make suggestions to do that. So in other words, the proportion of using the AI in the entire life cycle of improving the system getting more and more weighted. So eventually, it's AI going to dominate. Remember before when we do the data mining, we actually humans at the driver's seat, right? Because we design the system, we do that, right? So now, as soon as you open large language model can do things, let's let it do it. So eventually, they're going to dominate all the process, right? So that's actually one of the danger people feel like that OpenAI will pose to human race because they started creeping in and then replace our way of thinking because you have too much like that. So the educated data mining, given that we actually gain insight from the interactions. So do you have concerns on that?
I don't know. I don't have concerns right now. I mean, I guess this is maybe not an interesting answer, but with this technology, it just kind of depends what people do with it and what they do with it. I almost feel like I have to evaluate on a case-by-case basis whether it causes me concern. I mean, obviously, the reaction of the public and issues with trust and they took our jobs kind of mentality is really hard to predict. One application that I think is really a slam dunk, and I think a lot of teachers very easily buy into, is using language models as a tool to generate the content that they're already kind of creating, like, create a first draft that they then edit. And, maybe through that kind of use, people will become more comfortable with the technology. Because I can imagine, writing a traditional intelligent tutoring system is very time intensive. So even using language models as a kind of authoring assistant where they're creating rough drafts of some materials that you then massage into what's needed for an intelligent tutoring system can be a huge time saver. Just as like a little anecdote, I was once on a project where we created a biology intelligent tutoring system that was very closely matched to the Tennessee state standards for biology. So they had these like end of course tests, right? And we had to match to the test for the schools to be interested in putting our system into their schools, right? So we did this for about 2 years, and then Tennessee changed the standards. And so all this work that we had done on creating all this matched content, I mean, it wasn't like it was thrown away. I mean, it was still biology, but it was significantly changed. So almost every single thing we had done, we had to go back and mess with. And I can only imagine that having large language models at that point to help us in that process would have been great. I mean, it would have saved us so much time. So I don't know, maybe I need to go out and make another biology tutor now.
So actually, this is good. So right now, I want to since Gautam is not, I do not see his name over here. See, he has some other applications. So let's talk about the thing that you do, Main, and also Richard and myself. We all do. As soon as the large language model comes in, all the students use it to write papers. And for us, for the learning scientists, and then probably only we realize how hard it is to create or to produce good tutoring system, because our content producing is just simply too hard, right? Now you actually had I remember you had a project of producing content, like automatically producing content. Having the large language model come in, are you extremely thrilled, or do you have like a fear that if we producing the content like this, maybe it's the same fear like, oh, students just producing papers like this. They're producing papers, they turn in without reading it. Do you feel like that same danger, the learning, the resource producers of like us also have said, well, the large language model producing good content, there you go. You mentioned about having kind of, like a screening it or having OpenAI or large language model giving some content. I just, I will select which is best. Do you think we will do that, or how likely people gonna do that when there is a huge demand of content, and then you do not have time to do that? So, Andrew, so in other words, in terms of using OpenAI to producing content, what are those advantages? What is so exciting, and whether there's anything that you have concerns?
So using something like OpenAI, so also kind of answering your question and maybe continuing some of the conversation that's currently happening in chat. What I'm currently doing, which I think probably everybody is doing, is when I have an idea for a specific task, I always go to one of these large language models first. Like, actually, I like to use Bing Chat a lot because I can just do it in the browser and it's free. But and see how well it does. Because if it does it really well, then I don't know that I need to spend a lot of time like putting together a data set and fine-tuning a model, right? And sometimes it does amazingly well, and I think, well, I guess I can just have a project or a paper where I'm evaluating how well it does, right? And so, then the question is whether or not I need to assemble a data set or try an alternative. But at least, using one of these large language models as a baseline, I think, it's almost like it should always be a baseline now. Because if what you're doing isn't competitive or better than, Bing Chat or whatever, then why are you even bothering to do it? That's kind of my opinion right now. Of course, my perspective is really shaped by the communities I participate in, where there are standardized tasks and leaderboards and things like that. So I'm not trying to say that if you have an innovative new approach, you shouldn't try it if it doesn't compare well to ChatGPT. But a lot of the things that I do, I just really wouldn't bother if I couldn't at least be as good as or better than.
So, Min, I want you to share your experience of using it. Are you using it to generate content or verify content? Because I know that one of the few highlighted use of large language model is really write programs. I know that you build tutoring system for a software, building teach people how to write, learn software engineering, right? So,
Yeah.
So what do you feel?
I think teaching, when first of all, large language model, and so some of the times in the past, a lot of AI and machine learning conference, there's always like large language models try to submit the paper, and they try to kind of see how good the reviewers are, and those papers is never get accepted. So clearly there is still value for people generate the paper and submit. Of course, you can polish, but the original ideas still come from the people. And that's one of the things make me more feel like it's comforting to the graduate students that it's still value to do your creative job other than just let ChatGPT do the creative part. So the second part is about a large language model. I think a lot of times it can tell you what is right. It's hard to tell you students when they make a mistake and why and how to intervene. That's part when it's like when students learn, is this aha moment, right? And so that's one part I feel like ChatGPT can generate great, beautiful bullet points, but if I saying that how should I improve for the certain skill for the math or something, they will give you very general, but not the pinpoint to the things that I actually need something other than like general guidance. So that's kind of the things that we still need the human teacher and also social. The ChatGPT tell you great job and so on. It's different from human, right? That's a trust and privacy, data privacy, another big issue. And the ethical things, all this is, I think, a large language model has potential risk and also need to, when people deploy large language model, has to consider.
Okay, Richard, I know that you actually in your previous effort of working with a learning company, and I know that you probably company spend a lot of effort producing content. Every content should be 100% correct and then efficient and effective. So now we have this this monster coming on us. Are you excited from the industry perspective, or are you overly concerned about the quality? Because once you have massive amount of production, and then how can you control the quality? Share your views.
Yeah, I mean, I think Andrew covered a lot of that. Also, Min talked about it also. So large language model currently has a lot of limitations. So it's really good with certain type of generation, but large language model itself is what we call a very thin and wide model, right? So it has a lot of kind of like a common sense capability, but it doesn't go very deep. So that's a problem, especially if you want to align that with your pedagogy and the specific student struggles, like Ming was talking about. If the large language model have a generic knowledge and it sees the problem that the student make mistakes, it tends to generate very generic type of advice. A lot of time because it doesn't understand the content or doesn't understand the specific scenario that student is struggling. So a lot of the whys seem to be very shallow, right? So that shallowness is very troublesome to use it for kind of like a really personalized type of personalized content generation. And another issue with large language model, actually, let me show my screen again just to illustrate this point here a little bit. Where was that? Can you see my PowerPoint?
I see your desktop.
Beautiful.
You cannot see the PowerPoint?
Yeah,
No,
okay.
that is now we can see.
Okay. So if you see here, the large language model have four, I think, big limitations. One is unpredictability, and the other one is hallucination, right? Sometimes it's generating stupid answers and so forth. And accuracy with math is problematic. And another thing is inability to discern truth from falsehood. So a lot of time that is, it's giving really kind of like, again, in math and science, it's actually sometimes generate bad answers that could be very misleading. And the fourth one is a lot of times need a symbolic mechanism. Like, for example, when we want to align that with pedagogical content and so forth, is still troublesome because it's a shallow model. The shallow model doesn't know your specific need and doesn't know the deeper knowledge. So when we're talking about like using that in the field, right? So I see that having three levels, the ChatGPT and large language model in general. One is to generate content and so forth. The second one, what I call is interface for a learning environment. It really can behave as a global translator and communication mechanism to translate a lot of the complex input and complex contextual information for the learning environment. The last one is that it actually could be a reasoning engine for adaptive kind of like education for the adaptive engine to make decisions using large language model. The problem with the generation, it has to be generated along with the context information, like the one that I was showing earlier, that you have to really generate it alongside with the kind of like the contextual information so that it will generate relevant and also accurate information, and also need human in the loop so that you can update it and curate it before you can show them to that student. If you're generating online dynamic information like a feedback and so forth, there need to be a filter. There need to be what we call a guard. Basically have to be a guardian against generating bad or inaccurate or sometimes misleading information. And that is really needed. That's why we're saying we need to have agent technology on top of large language model in order to achieve that. And also, we want to leverage existing expertise and knowledge and assets, right? So that is where we need to think about how do we combine fine-tuning and also retrieval augmented generation and other kind of like a more symbolic and neural, cognitive architecture combined to achieve that. And that is what is critical for the long-term success of large language model in the education field. And I think by itself, large language model could be very limited. But combining that with agent and neurosymbolic combination, I think that is it's a future. So, yeah.
Okay, I think that's a great answer, and also make us to have the next discussion. So, as we large language model is only a year old or less than a year old, making us crazy like this one. We can only imagine in the future it's going to be even worse, or even worse. I mean, so one of the milestones of OpenAI is having the plugin. So once you have the plugin, trying to for example, for the math, you plug into a Wolfram Alpha for the hallucination. You get a Scholar AI. So what you're proposing is almost like having a plugin for pedagogy. Because remember, large language model is not built for learning. And now we're commenting where I say, oh, you're not at learning, do not understand the student. Is that that shortcomings are by design, by theory, or by implementation? If it's by implementation, that means we actually can build maybe add a plugin for that. If it's by design, no matter what you do, we're not going to help. It's not going to work. Right? If it's theoretically, forget it. You're just a bunch of models. You cannot understand a human. You behave like a human, but you do not understand. So I want to have the last 10 minutes. Let's discuss this one. How can, as a learning scientist, instead, of course, we point out what the issues with large language model. Can we help, and also can we build, or is it possible build like a plugin? Like pedagogy plugin, like what originally you were talking about, is almost in my mind is like a pedagogy plugin for large language models, right? And then Andrew, you actually did a lot of study on large language models. So how can we either repurpose or do something to large language models that serve students much better than what we can see right now? So share your views, Andrew.
Yeah, it's a great question. Sorry, I'm just making sure I'm unmuted. I'd really like to, it'd be so great if we had lots of excellent human tutoring data. I know that there are some online platforms that do tutoring. I don't know that, I can't think of any that do the kind of tutoring I'm talking about. Like, I'm not talking about like homework help me solve this math problem kind of tutoring. I'm talking about like deeper tutoring, like starting from scratch on a topic. But I think it would be so great if we had a lot of that, and that we could start trying to train up models on this and then explore the possibilities of those models, because it's not clear to me that if we could do that, that the models wouldn't be, I think maybe the models could be successful. I'm not sure how much we need. And I'm really not sure what the limits on generalization are. Like, especially, I mean, I guess maybe you could think of this as maybe kind of a fine-tuning task. If you already started with a large language model and then you started feeding it lots of tutoring conversations or tutoring transcripts, what exactly could it pick up on? But I imagine it would be able to pick up on a lot of good naturalistic pedagogy. And I'm sure there are a lot of educators in the call. I can tell you from grading my classes year after year that students tend to make the same kinds of mistakes over, like different students will make the same kinds of mistakes, right? So how many interactions do you really need in order to cover 95% of those? So that would be something I think would be a really nice project. Maybe maybe the government, someone will fund some really massive collection of tutoring data like that.
Okay. Any other thoughts?
I would also add a little bit to Andrew's earlier talking about coding of these conversations for future pedagogical use. I think a lot of these, if we go back to the way that originally we designed this pedagogical approach, these heuristics, like for example, when we say using a Socratic way of teaching student, or using a different approach, explaining and try difficult questions first, or try easy questions first. A lot of the strategies directly impact how those conversations will shape up. And the way that a certain strategy directly impact the shot by shot workflow or within a conversation. So I think that with large language model right now, if we combine that with the contextual like a strategy and say, I am a agent that built to use a Socratic method to teach a student, and we think this is the way to go, that conversation probably is going to end up very differently from another agent that is using a traditional explain and then try your first, and then I'm going to give you feedbacks on your mistakes without telling you the answer, those type of approach, right? So that's what I feel like a lot of the traditional coding mechanisms, does this still apply, or should we really evolve from this traditional mechanism and use a more contextual and also what I call a model fusion mechanism, where you're combining a lot of the system one type of intuitive type of things that large language model is generating with the system two type of systematic, analytical decision making to guide these conversations and build them together, rather than let them, do just large language model, which basically very, matter of fact or common sense type of approach, but it's not very reliable, right? So, that's just my opinion on that. And hopefully that's something we can explore to see how this data can come back and then tell us whether this strategies works or not, and also what are the mechanisms for them to get used.
Mm-hmm. So we have, go ahead, B.
I will just follow up on Andrew and Richard's points that I think they made excellent points. Another thing I feel like a lot of times they are too verbose when you compare with in classroom settings, and also I don't want to read a paragraph to get what's your point. Just give me one action, I can do it. And that's one of the things in order to be large language model to be useful. And also you need to model both the teacher, classroom, and the students in order to be eventually be deployed in the classroom. That's it.
So I have 5 minutes. Let's I saw that Andrew and also Richard have been discussing with the post with others. So let's see whether we can have a concluding remark. 1 minute for each of you. Concluding remark. Just anything that come to your mind after the discussion.
Well, let me do first. Okay. I think we're really at this inflection point for the AI education. And there's a tremendous promise. And also, I think there's a potential paradigm shift where we can getting much more scalable solutions and also having a totally different new type of systems that can be deployed within a relatively short period of time. But at this time, I also think there's a lot of challenges, especially around the hallucination or the untrustworthiness of a lot of large language model generations, or the black box models of these neural systems in general. And I feel like we need to come together, not only from standardization and other ways of, getting the whole field to rally to the same type of direction, but also looking into, in general, how AI itself will evolve with us to move the education for a more equitable and accessible education for everyone.
Okay.
Yeah. I'll go ahead and go, I guess. Do you want to go, Min?
Go ahead. No, go ahead.
Okay. Yeah. Yeah, it's tough to have, I think, to have kind of final thoughts here. I totally agree with the inflection point. I remember working in computer vision like 15 years ago, and we would use like features, like we would get images and we would calculate features, and then we would do things with those features, right? And then deep learning came along for vision and changed the paradigm, right? And I feel like what we're seeing with large language models is kind of similar, but more with knowledge. So I used to create symbolic programs that would read text and construct knowledge bases and do all this stuff with knowledge. I don't have to really do that anymore. The language models do almost all of that for me, and it's amazing what I can create in like a week. Like literally, I can create something in a week that took me a year, like 15 years ago. So it's really amazing, but of course there's this, some of the issues that Richard pointed out. The issues with hallucinations and stuff, I think, a lot more work needs to be done there. I'm personally finding in a lot of things that I do in highly technical domains that anatomy and physiology is something that I've been using large language models on a lot because I have a project on teaching anatomy and physiology. And I don't really see too many problems with that. In fact, we have a fielded system. It's been fielded for, I think, 2 years, where we're actually generating like feedback for people, and it's not filtered at all. Like when they make mistakes, we're generating paragraph reputational feedback on their mistakes for them. And it's okay. Sometimes it makes a mistake, but it's decent. So yeah, but it's definitely challenging to think about how to integrate these things into larger systems and exert the kind of control that I think we often feel like we need. And so that's what I see as one of the big horizons in the near future.
Mm-hmm. Mm-hmm.
So I totally agree with Richard Andrews' excellent points. And I teach data mining machine learning for graduate students, and we have a project. And I said, please don't use ChatGPT to generate the project report. And because if you are, so for us, we have experience writing first paper is awful, and learn from recycle advisors, supervise, and eventually we write okay stuff. And then now we look at the ChatGPT generates and we can spot where it's wrong. But students who haven't trained to the level doing expert writing, they think everything ChatGPT, they can spot the bad points. They don't have that learning process. So what I think ChatGPT made is extend the education longer, because all these students need to get there and be able to be useful in industry. And instead of they can now get out of the door, they probably need to learn how to interact with ChatGPT and how to spot what ChatGPT generates stuff is not good enough. So I think that means we do need a tutoring system about how to interact with ChatGPT and how to use and find misconceptions in the whole world of large language models. So that's my sense. Very shallow one.
Okay, thank you very much. I think I assume we just stop at 8 o'clock, but I see a lot of discussions, and I welcome to just contact every one of us, and then continue the discussion. But there is 1 hour is not going to do the service to discuss this topic in depth. But I do feel like we covered some of the ground. Hopefully that the empowering learners.ai will have annual conference, the panels like this. We actually going to have a real face-to-face meeting in ASU in about a month and a half. So welcome everybody to join. So I guess we that's all we need to do for this panel. There's another panel session, another session going to go on. Okay. All right.
Thank you very much.
Thank you for
Thank you very much.
participating. Yeah, and I think let's keep discussion and keep in touch.